So welcome to everyone watching this video. In the previous videos, we have completed making this nice looking hacking screen. In today's video, we are going to be editing our code to make it even more memory efficient. So as you can see here, it is currently using 9% of the CPU and using a lot of memory. So let's just try fixing that by editing our code. So before editing our code, we need to first analyze it very well. Here we have imported these three libraries. For the first is for basic C programming language features. The second is for using the features such as the system function, the rand function. And the third library that we have imported is for using a useLeap function for pausing the program every after every line has been printed. As you can see, it is not continuously getting printed, but it is pausing after every single print. Now what we need to do exactly is analyze this and change it so that it is more memory efficient. For that, as you can see, I think so we have this line. Okay, we have this system clear line, and we also have this printf line right here. These two lines have been repeated again right here. So let's just reduce this repeating. Why are we repeating this line at the first place? We have this code. Initially, we want to clear the screen and then we want to print this big hacking message. Now, why are we doing this? Because initially the value of int I is 0, and then while true, we are checking if I is 15, then we are going to perform all of these things. When I is 15, if we are performing all of these things, why not keep the value of I initially at 15? So let's just turn it to 15 only, remove these two extra lines of code, and I think so we have fixed quite a lot. Now, this will work for sure. And let's just check what all we can change more. Okay, I think so. We are printing this hacking message, which is basically stored inside of a character, right? We have stored it inside of this character hacking. Now, the issue with this is we are declaring a new variable, and we are then using it only one time. So instead of declaring this new variable, why not copy all of this? Control C for copying. Actually, we need to cut this time. So Control X for cutting and paste it directly here. Why not do this? Okay. So now we have pasted it directly here, right? Let's just remove these two things. And you can see also, let's just remove the %s also, because initially we were concatenating the string. And we can also remove these two things, and I think so we have made it even more efficient. Another problem is that we are using printf. Printf is generally used when we want to format the string, but in our case we are not formatting it anywhere. We are not using any %s, %d, %u, whatever we use. So let's just remove the printf and write in here puts. Puts is basically a very basic function for directly printing whatever we want that we have completed. And I think so we should remove these spaces, because yeah, we need to remove these spaces. The reason is that whatever we would be printing, right, will have some extra space that we know that we really don't want. So now I think so we have removed all of the spaces that were unnecessary, and that also reduced storage. Now we can also see we have this system function. What does this system function do exactly? It calls the system call, and then it tells it to clear the terminal, right? But using a system call inside of our C program will also reduces efficiency. So let's just replace this system function with puts. And what are we going to print here exactly? We are going to use something known as ANSI codes. Here we have used an ANSI code already to make the text green. We have more and more ANSI codes for altering how the terminal is working. So for example, if you want to clear a screen, we also have some ANSI codes for that. Let's just go ahead onto our browser and search for clear screen ANSI code. That should be available. Wow, our favorite website, Stack Overflow. Okay, so what they have written, if you want to clear the screen, the ANSI sequence in a printf. So you can use it in a printf or even in Python if you are using print or anywhere you can use it. It is basically they are telling that if you want to use the printf function which is built in inside of your terminal, you can use this. But currently we have a different situation. So let's just copy this. What does this do? This clears the entire screen. And I think so. Before clearing the entire screen, we also need to put this because first we need to align our cursor to the top left of the screen and then we want to clear whatever is on the screen, right? Let me show you what I mean. Uh, yeah, here you can see our code is running, right? What needs to be done is we want to take this gray colored box, as you can see, that is basically the cursor, and we need to move this to the top left of the screen and then clear the screen so that the screen actually gets cleared. For that, we are going to use this puts function, and what we are going to type inside of it, we will type this specific thing, which is firstly, we are going to clear the screen using this ANSI code, copy this, paste it in here, and then we are going to align our cursor. Actually, first we need to align the cursor, I think. Okay, so first let's just align the cursor and then clear the screen. This should work fine. Okay. Also, if you have noticed, we are again using two put statements. Why? Let's just combine all of these into a single statement. So we are clearing the screen here. Then after clearing the screen, let's just put the command to make the screen color text green. Now, uh, I think so we should run the code right now just for checking purposes because never ever do this in your life if you are using a programming language such as C or C++. In the meanwhile you are coding, you should also try to rerun the code. That is extremely important. Now let's just take the hackers dot c file, hackers dot c file, and compile it. So okay, so there is an error. Now the issue is that in programming languages such as C programming language or C++, these are so complex you won't know what errors you have left at the past, and it will take you months to actually repair that error. Here you can see this we have left this. Okay, so editing this will take additional time. Nice. Now we have coded this perfectly. Let's just try running it. So okay, the code seems to be working fine. Now what we need to do exactly, we also have this while statement. Let's just change it. So change it into a label and a go to statement. Go to statement is not something which I would recommend to use in your like programs. I'm using go to because it is just a single statement that will be running throughout. So go to label. So what is going to happen is that while true was doing this same thing, it was just repeating this part of the text continuously, this part, but we just replace it with the go to statement while. While loop checks the condition every single time, while true. If the condition inside of the brackets is true, then it will continue, else it will not continue. Why to check this condition continuously when we can just directly use the go to statement? Because anyways, it is going to be true always. Whenever you need a condition to be checked, then you should surely use while loop because in that case, that is more efficient. Here we don't have such condition. Now, what all things can we do more? Mm, I think so. We have this int statement. Let's just use something different than int. Okay, so as you can see, the range of our int is from 0 to 15, right? Yeah, our range is from 0 to 15. So we don't need int which has a huge range of negative numbers and positive numbers. So first, let's just try using something like which has extremely small range. I think so that is from 0 to 255, right? That is for u int underscore 8. No, actually u int 8 underscore t. I think so that is that, right? Yeah, so that is working fine. But again, there is an issue. Uint 8 underscore t is defined inside of a separate library named stdint. So importing an extra library is not what we want. So let's just remove this and use something which is present inside of our stdio.h itself. Let's just check where inside of which file it is present. Yeah, you can see provided by stdint.h. Yeah. So let's just use uh, unsigned, unsigned and short. So let's just use this. Unsigned means it will never be negative, and short means it is really short bytes. Okay. Now, I think so. We have also made this part of our code very efficient. What all can be done even more? Yeah, I also see one more thing. We have this rand thing, right? Rand is always positive, always returns a positive value, and it is also within the bounds of what is expected. So let's just use percent %u instead of percent %d. Percent %u will just give us an extra functionality of like adjusting like how much formatting needs to be done and all of this. Percent you would take care of that, because anyways we were not going to use percent d in our case, so it will also make our program more correct. What more can we do in our code? I don't think so we have anything else that can be done to make it even more efficient. I think so. This is quite nice. Go to return zero int main. Yep, I think so. We have made this as efficient as possible. So just for checking if it is working fine, let's just go to our terminal, which is currently using 0.05% of the CPU, or 0% you can say, and let's just try running the code again. Actually, it will not make a huge amount of difference, because C already is extremely efficient programming language, something which is extremely close to the system. So I don't think so it will provide any like extraordinary kind of efficiency just by changing these kinds of lines. So let's just try compiling this again. So GCC dot slash hackers dot C. Yep, that is done. Now dot slash a dot out. Okay, now our code is running, and let's just see the efficiency of our code. Oh, what is happening? It is scrolling. 1 minute. Okay. Oh, so I think so. We are calling this system clear function, right? So it is working fine if you will just see with your eyes, but it is not working fine in the terms of if you are looking at like this. Like if I am looking at this with my eyes, I think so the screen is getting cleared and the cursor is running. But if the moment I touch the mouse and scroll a bit, you can see it is actually continuously printing and aligning the mouse at the top, making an illusion that it is clearing the screen. uh, so I think so it is better in our case that we are not using a system clear. It might also depend on the terminal. We are currently using just 4.37% of the CPU, which is nice, which is efficient. So I think so we have quite fixed our code. And just for the terminal which currently I am using, let's just fix it. So I think so instead of using the this part of clearing the screen, I can use the system clear as well. But again, doing a system call is not always feasible. Let this be. And now I think so we have optimized the performance of this code to be at max. Now let's just try to optimize its storage. So let's go and optimize its storage. So as you can see, I have opened the hackers file onto my Linux system, and you can see we have the same code that we have redesigned. Now, to actually enhance the storage, what we need to do, we will first try running the same code in GCC. So dot slash hackers dot c. As you can see, we have compiled the code, and dot slash a dot out. It works the same on every system, even on Linux, on Mac, on Windows, anywhere it will work the same, because we are using the very basic libraries of C programming language. Now, To actually enhance the storage, we first need to check how much of a big file is being created by GCC. So GCC is currently creating 15.6 kilobytes of a file. Now, we need to reduce 15.6 kilobytes into like very less, as low as we can go. For that, we are going to use another compiler named Tiny C compiler, TCC. So TCC dot slash hackers dot c. Now, let's just try running the a dot out. It is working the same actually. I think so. It's working even better, even faster. And let's just check the file storage. You can see it is now just 4 kilobytes, just 4 kilobytes, which is almost nothing. And you can see the same code which was compiled initially by GCC was about 15.6 kilobyte. Now it is just 4 kilobytes, which is very less. So thank you guys for watching this video. Be sure to like, subscribe to the channel, and click on the notification bell so that you get notifications on my latest videos. Thanks for watching. Take care.